6, which is the first lesson in topic 2, term 1 material, and the topic is reaction rates, and the title of the lesson is a model for reaction rate. To start with is, what is the meaning of reaction rate? So when we say reaction rate, what is meant by rate? I'm sure you heard about this word previously in physics. So when we say reaction rate, rate is another word for speed. As you are aware, some reactions are fast. They take place at a fast rate. For example, fireworks. Fireworks is considered as a fast reaction. Some reactions may require, for example, 40 minutes, like baking a cake. Baking a cake, this one requires 40 minutes. Okay. Some reactions require days or weeks even rusting. If you have something that will be allowed to rust, this will take a very long time. Maybe it will take 1 month for iron to rust. So whenever we calculate the reaction rate, this means we calculate the reaction speed. Now, you know from physics that speed is equal to distance divided by time. And its unit is meters per second. In chemistry now, we don't have distance because the reactants and the products do not move a distance, they stay in place. But we do have time. So in chemistry, I will replace the word speed with RR. Now distance should be replaced with something else, and I will keep the time. So it will not be meter, it will be something per second. Now what is this? And what is this? You will know within minutes. Now this is the speedometer of the car. This one measures the speed. I want you to note something very important. The minimum speed is 0. The speed is never negative. So reaction rate cannot be negative. It's always positive. Okay, so the reaction rate is positive. It cannot be negative. The minimum is 0. It cannot be below 0, even if the car is moving backward. That's what you usually say in classes. Even if it's going backward, the speed will not be negative. So the reaction rate is the speed of the reaction. It's positive, and it is something over time. Now I need to find a replacement for distance. What should I replace the distance with? Okay, let's look at these 4 containers. First of all, I want you to tell me what is the time in each image. Here the time is equal to 0. This time is 10. This time is 20. And this time is 30. Now let's observe what's happening during this time. According to this reaction, the red is the reactants and the blue is the products. Now let's see what's happening to the reactants and what's happening to the products. First of all, I want to count the number of reactants here. I think they are 20. Okay, so I have 20 reds. Now how many products do I have? Which is the blue? I have 0. Why? Because the reaction did not start. The time is 0. I have all reactants. I don't have any products. Okay, now let's come here to this image. Now what's happening to the red? The red is becoming 2, 4, 6, 8, 10, and the blue are 10. Now what happened to the reactants? The reactants are decreasing and the products are increasing. Now let's see this image. The reds are 5 and the blues are 15. Now again, the reactants are decreasing and the products are increasing. Now here the reactants, the reds are 2 and the products are 18. Okay, so what's happening to the reactants? The reactants are decreasing. What's happening to the products? The products 0, 10, 15, 18, so the products are increasing. Now, can I say that at this time the reaction is finished? No, because still 2 reds should become blue. Now, when the reaction finishes, you should see only blue in this container. So the reactants should become 0 and the products will be 20. I guess this will be after like 40 seconds. Okay, so notice that reactants start from a number and then at the end they become 0. The products start from 0 and then they increase to a number. So reactants will decrease and products will increase. So that's what happens in a reaction. The reactants change and the products change. So let's come back to this rule. Now, instead of distance, I will say reaction rate is equal to change in reactants over change in time, or it's equal to change in products over change in time. Because here we have two things changing. We have the reactants changing and we have the products changing. So we can either use reactants or we can use products. Because the reactants are decreasing, so whenever we do delta R will be negative. And I said the reaction rate should be positive. So whenever we are dealing with reactants, I will put a minus sign, which means that this value is positive. Minus times minus, this will give you a positive. For delta P, because it's increasing, so delta P will be positive, so no need to put a minus sign. So this is the first rule you need to memorize in this lesson. RR equal minus delta R over delta T or delta P over delta T. Okay, now let's do another question. Let's look here. As before, put the times in each case, put the reactants, which is the squares, okay, and see the products, and tell me what's happening to the reactants and what's happening to the products. Pause the video and do this exercise. Okay, now this is what we said before. Now let's do this question. Now we need to calculate average reaction rate. In a reaction between this one and this one, 0.220 at the beginning of the reaction, so the amount is 0.220. At 4 seconds, this one is at time equals 0. At time equal 4 seconds, the concentration is 0.100. Now calculate the average reaction rate. So I need to calculate RR. Remember, RR could be calculated in one of two rules, either minus delta R over delta T or delta P over delta T. Now, which one I'm going to use? I don't know whether this amount is a reactant or a product. Can you figure out if this is a reactant or a product? طبعا, anything that decreases is a reactant. So this one is decreasing 0.222 to 0.1. So it's a reactant. So I'm going to use this. So I will say RR equal minus delta R over delta T. You know very well that whenever we say delta, delta means final minus initial. This is not only in chemistry, guys, it's only in all subjects. So delta is final minus initial. Now in chemistry, the final is the product and the initial is the reactant. Okay, طب هلا delta R. Final delta R is 0.100. I will keep the minus outside. 0.100 minus initial 0.220 over the time is 4 minus 0. Okay, and then you calculate the answer. The answer should be positive. If it was not positive, this means there is something wrong. So the answer will be 0.4. I think it will be 0.3. Now the unit is m and the time is second, so it is m per second. Remember, in physics, it's meter per second. In chemistry, it's molarity per second, m per second. Okay, now in this question we have time 0, 0.5, 1, 1.5, 2, 2.5, and then we have the concentration of H2SO4. Now is this concentration increasing or decreasing? This is decreasing. Why it is decreasing? Because H2SO4 is a reactant. So during the reaction, this one will decrease, this one will decrease, this one will increase, and this one will increase. دائما reactants decrease and products increase. So these two will decrease and these two will increase. Okay, now the question says calculate the rate between 1 minute and 2.5 minutes. So this is 1 minute and this is 2.5 minutes. Now this is a reactant, so I will say RR equal minus delta R over delta T. Now, reactant, final 0.10, initial 0.40 over time 2.5 minus 1.0. And the answer will be 0.2. Now, the unit is copy this one. Note that mole per liter is the same like capital M. So either you say moles per liters or capital M over minute. If the time is given in minute, do not change to second. Keep it in the unit it is. Okay? Another question. Now let's look in this graph. According to this graph, this amount starting from 0.65 and then it is decreasing. And decreasing means I am describing a reactant or a product. This is a reactant. Now, if it says on the same graph plot the product, so what will you do? You will start from 0 and then it will increase. This is the product. Usually the reactants will decrease and the products will increase. So this is the way you draw it. Now the question is calculate the average reaction rate between 20 and 100 seconds. So I want RR. First, let's agree. Will we use minus delta R over delta T or delta P over delta T? Now this one is decreasing, so it's a reactant. So I will use the reactant formula. So minus delta R over delta T. Now I need initial R and final R, and the times are 120. Okay, so I will look at the time of 20. And then I know that the concentration is the 3. At 100, the concentration is 1. Okay, so I'll keep the minus outside. Now, final is 1 minus initial is the 3 over time 100 minus 20. Okay, and then I will do the calculation. And the unit will be moles per liter, this one. And the time is second. Over second, okay? Or you can say instead of mole per liter, M over S. Okay, now let's do this question. Now pause the video and try to read the question and try to solve. The question is calculate the rate of disappearance of HCl. Before you do this question, I would like to point for you something very important. If you have this reaction, 2A plus 3B gives you C plus 2D. Now I want to write the reaction rate for A. Now A is a reactant, so I will put minus delta A over delta T. Now what about this 2? Don't forget, this 2 will become 1 over 2. Whenever you see a coefficient, you make it 1 over the coefficient. Now for B. It's a reactant, so I'll put minus. This 3 will be 1 over 3. For B, delta B over delta T. Now with respect to C, C is a product, so no need to put minus. I will say delta C over delta T. Now for D, also it's a product, so we don't put a minus, and the 2 will become 1 over 2, delta D over delta T. So this is the way we write the reaction rate. Now pause the video and write the reaction rate for this reaction. Okay, pause and write RR with respect to H2, with respect to O2, and with respect to H2O. Okay, now check your answers. So don't forget, if there are coefficients, you make them 1 over the coefficient. Okay, now let's go back to the question. Now what I want from you to do is, I want you to look at this question and write for me RR for each one of these. Okay, now with respect to Zn, what is the reaction rate? Minus, because it's a reactant, delta Zn over delta T. Now with respect to HCl, also it's a reactant, it will be minus, the 2 will be 1 over 2, delta HCl over delta T. Now with respect to ZnCl2, it's a product, so we don't put minus, it will be delta ZnCl2 over delta T. And with respect to H2, delta H2 over delta T. Now the question is calculate the rate of disappearance of HCl between 4 and 6. So I will be looking at 4 seconds and at 6 seconds. Something very important that students did last year and they lost marks for it was they said RR equal Now HCl is a reactant, so I will put minus delta HCl over delta T, and I will put minus. Now the final is 0.053 minus 0.065 over 6 minus 4, and they forgot the half. If you forget the 2, which becomes 1 over 2, you will get your answer wrong. So be careful. Here it should be 1 over 2, and here you should put 1 over 2. And then when you find the final answer, the unit will be moles per liter times second. Okay, now I want you to do this question. The question says, calculate the average reaction rate of B between 3 seconds and 6 seconds. So this is the time, this is 3 seconds, and this is 6 seconds, and you have to calculate the reaction rate. Now, I don't know if B is a reactant or a product. How can I solve this problem? B is 0.8, 0.6, 0.4, so this is decreasing. And you know, anything decreasing is a reactant. Okay, so minus delta B over delta T. Okay, now the final B is 0.45 minus initial 0.6 over the time 6 minus 3. Okay, and you find the answer, and the answer will be moles per liter second, or instead of moles per liter, you can write capital M per second. Okay, now let's look at this question. This question says Mg, HCl, MgCl2, and H2. What happens to Mg and HCl? Now these two are reactants, so they will decrease. These two are products, so they will increase. So the concentration of MgCl2 will increase and HCl will decrease. Now, if you were supposed to draw the graph for the reactants, usually the reactants will start from a number and they will decrease, they become 0. The products will start from 0 and they will increase till they become constant. So usually the reactants decrease and the products increase. Okay, now let's look at this question. This question says, which substance is a reactant? Justify your answer. As we said, reactants are the ones that decrease. So N and Q. Why? Because they are decreasing. Now, which one is a product? The one that starts from 0 and increases. So this is M. Why? Because it is increasing. Now, the question is, calculate the average reaction rate for Q. Q is a reactant, so I will use RR equal minus delta Q over delta T. I put a minus because Q is a reactant. Now between 10 seconds and 20 seconds. So simply I will go to the graph. 10, 20, be careful, I'm going to draw for Q, not for N. This one is 0.2 and this one is approximately 0.1. So I will say minus. The final amount is 0.1 minus initial amount 0.2 over the time, which is 20 minus 10. You find the answer, it should be positive, and the unit is moles per liter over second. Moles per liter second, or moles per liter is capital M over S. Now this question is from last year exam questions. You have 2B plus C giving you Z. The graphs were plotted. Which graph is correct? Explain your answer. I want you to pause the video now and to answer this question. Okay, now if B and C are reactants, so the graph should show that they are decreasing and Z is increasing. Here B and C are increasing, so this is not correct. This one, B and C are decreasing and Z is increasing, so this is correct. So the graph Y is correct. Why? Because B and C are reactants. They should decrease. Z is a product and it should increase. Okay, so read this statement, pause the video and read the statement. Okay, now we want to explain something called the collision theory. Now, according to this graph, A2 and B2, what do they represent? They represent the reactants. Okay, now 2AB, what do they represent? They represent the products. Now, how can we tell that there is a reaction taking place? Now, the reactants, notice that there are two purples together, two yellows together. In the products, one purple bonded to one yellow and one purple bonded to one yellow. So these two are not the same like these two. This means that there is a reaction taking place. Now, my other question for you, do you think reactants change into products directly? No, they make something in the middle. This is called AC. A means activated and C means complex. Now, activated because it's active. Active means it's full of energy. This compound, as you can see, these yellow rays, it is full of energy. Is this compound stable or unstable? It is unstable. Why? Number one, because it's full of energy and it needs to break to make the product. So it will use the energy to break from here and give you these products. So activated complex is unstable. It is formed between reactants and products, and it breaks down to form the products because it's full of energy and the energy should be used somewhere. So, هلا collision theory is similar to this game that you play, which is the billiard. Now, before you play the billiard and you want the balls to go in the corners, okay, what are the three things you need to do before you start playing? Number one, you need to choose the correct direction. By choosing the correct direction, you carry the stick and you walk around the table and you choose the direction by which you want to do the hit. Number two, what do? You choose the enough energy. You choose the amount of energy. If the two balls are close to each other, then you will push them with small amount of energy. If they were far from each other, then you will push them with big amounts of energy. So I'm not going to say small amount of energy or large amount of energy. I will say enough energy. So I have two things. I have to choose the direction around the table. And then I have to decide whether I will push with correct, with the huge amount of energy or small amount of energy. And number three, they will collide. طيب, is your collision always successful? يعني it goes here all the times? No. Sometimes it does not go here. Give me two reasons why the ball does not go to the hole. Either you chose the wrong direction or you didn't supply enough energy. So I want to tell you that this same thing happens in reactions. Each one of these is a reactant. Now, reactant molecules must collide with correct direction and with enough energy in order to make products. If they collide with wrong direction or with not enough energy, they will not make a product. Okay, let me show you how does it come to you in the exam. Now, first of all, I want you to look at these reactions and tell me which one of these reactions is a successful. Successful means the reactants, they collide and then they change into products. Now, as you can see here, blacks, grays, they are the same. So this one is not successful. And this one, black, gray, they are changed. This one, two gray, white, one gray, one white, one gray, one white. So this is the same. This one and this one, they are the same, not successful. And this one and this one, not successful. So why do you think here the collision between them is successful? Why do the reactants change into products? Two reasons. Number one, because there is enough energy. And number two, because there is correct direction. Okay, so these two reasons explain why do you think the reactants changed into products. Now another question. Okay, I want you to look here at these four figures and tell me which collision is successful. Okay, same thing here. When these two collide, here, no reaction. They collide, no reaction. Here they collide. This blue, brown went to this, so here this one is successful. Now here they collide. They stayed the same, means no reaction. Here they collide and they change, means there is a reaction. Why do you think there is a reaction? Because they did the collision with the correct direction and with enough energy. Okay, now take a minute to answer this question. Okay, so if they are energetic enough to collide but not in the correct direction, no reaction. They are energetic and correctly oriented. Orientation means direction. So whenever you see the word orientation, it is the same like direction. Okay, correctly oriented but too slow, also there will be no reaction. So the answer is B only. Okay, now what is the activated complex? It is unstable. It forms between products and reactants. Okay, now what is the activation energy? If you remember, we spoke about these graphs before, and we said there are two types of graphs. This one is losing energy, so this is exothermic, and this one is gaining energy, so it is endothermic. And if I want to label, this is R, this is AC, this is P, this is R, this is AC, and this is P. Now, if you are here and your house is here, this is the AE. This is the activation energy, the height of the mountain. Okay, same thing. If you are here and your house is here, this is the AE or the activation energy. Okay, now if you see that the activation energy is more, okay, where do you reach your house faster? If it was in this way or in here? طبعا here. Here you will reach your house faster, because you will approach here within less time, and here you need more time to reach your house, so this is slower. So the reaction is faster whenever the AE is small, and the reaction is slower whenever the AE is large. Okay, now let's do this question. This question is also from last year exam. You need to calculate the average reaction rate between 0 and 10. Can you tell me if X is a reactant? Yes, because here is a reactant and here it is decreasing. So you will use okay, and now it will be positive and the unit will be moles per liter times second or molarity per second. Okay, now which of the following, now we have this collision. Do you think this collision is successful? We have oranges, grays, they did the collision and here they changed. Okay, so this is successful. Give me two reasons. Number one, they were in the correct direction or orientation. And number two, there was enough energy. Now let's see the choices. This collision is successful, yes. A new product is formed, yes. Q and Z are not correctly oriented, خطأ, because they are in the correct direction. Q and Z are energetic enough to produce a new product, yes. So 1, 2, and 4 are correct. Yellow, now let's look at this question. Pause the video and answer. Okay, now they did not change the reactants. This is the activated complex and this is the products. They are the same. So this one is unsuccessful. Give me reasons. Why do you think this is unsuccessful collision? Because you have chosen the wrong direction and no enough energy. Maybe the energy is too low or maybe the energy is too high. So unsuccessful collision is true. Successful طبعا لا. A new product is formed لا. X and Y are not correctly oriented, yes. Okay, type. Now as we said, high activation energy means the reaction is slow because you need more time to reach your house. This is you, this is your house, this is the activation energy. So high activation energy means the reaction is slow. Low activation energy means you can reach your house faster. This one is fast and the AE is small. So as the AE increasing, the reaction becomes slower. As the AE decreases, the reaction will become faster. Okay, now can you tell me if this reaction is exothermic or endothermic? And this one. Okay, now we want to speak about the chemical reaction related to the spontaneity of the reaction. How is a reaction spontaneous? Spontaneous means It can occur alone without external factors. Okay, spontaneous means occurs alone. It does not need any factors from outside. Okay, now in this graph, it shows you the reactants decreasing and the products increasing. Okay, now we want to introduce the rate law, but I'm not going to speak about it now. I will speak about it in lesson 7. Also the unit of K. Okay, now I will skip these 2 pages till lesson 7. Now let's go straight to this question. Which reaction is the slowest? طبعا also I will explain it in lesson 7. How do you know from the what is K and how do you know if the reaction is fast or slow? Okay, that's what was all for lesson 6. Hope you learned something new.